Linear Motion 2014, question 1b. At a particular instant, a car of mass 1200 kilos is towing a trailer of mass 450 kilos on a level road at a speed of 25 meters per second when the engine exerts a constant power, given power this time, of 50 kilowatts. Friction and air resistance amount to 930 newtons on the car and 200 newtons on the trailer. Part 1, we're asked to find the acceleration of the car at this instant. Okay, let's do our diagram for these car and trailer connected by a rope. We'll call a string. We know it has tension in it. This one is the car, 1200. 450 for the trailer. It's going in this direction, so my A is going in this direction. We have resistance of 930 on the car. I'll just make that a bit bigger. 930 on the trailer is 200. And there's a force going forward this way, which we need to figure out now based on our kilowatts. So we've got 50,000 watts. Power is equal to force by velocity. We're looking for this force, so force is equal to power divided by velocity, which we have as 25. So our force driving this car forward is 50,000. To get it into newtons, over 25, and that would be 2,000 newtons driving this forward. So if we create our equations, F is equal to ma. So let's start with the car. It's going in this direction. So we're starting with our 2,000 newtons. And we're taking away what's going back, which is the tension in this rope or the string, and the 930. They're my forces, there's nothing else going on, and that's equal to mass 1200 times acceleration. With the car, I have, it's going in the same direction, so I'm starting with my T. So T minus, the only thing going back is 200. That's going to be equal to mass times acceleration. And we can see here, we can eliminate these T's. We're looking for acceleration. So we're going to get 200 minus 930. That's going to give me 870. 1130, 870 is equal to 1650 A. So A is equal to 870 over 1650. Type that into my calculator and get, let me do it correct, the 3 decimal places, 0.527 ms to the minus 2. Part 2, calculate the maximum speed at which the car without the trailer, no trailer, could travel up an incline of inverse sine 1/10 against the same resistance with the engine working at the same rate. Okay, max speed. At max speed, there's no acceleration. It's going to consistent speed. So let's do a diagram here. We're looking for the max speed. So that's the V from here. So this is going to be my unknown in this question. So with the force driving forward, the force driving forward for me will be 50,000 over V. Okay, so that's going to be up an incline. We have 1200 still. We have this F going forward, which is going to be my 50,000 over V. I'll put my angle in here, A. Coming down, we have 1200 G. Coming in this direction, I'm going to have my A in 1200 cos A, which we're not going to need, I don't think, in this question. And going this way, this is the sine A that they've given us, 1200 sine A. Now what is 1200 sine A? 1/10, 120 newtons. So let's put my R on, which we're not looking at this direction in this case. The resistance is the same, which was my 930. So my 930 is the resistance, and my acceleration is up the hill, which is going to be equal to 0 in this case. What else? That's it, I think. I think that they're all the forces. Let's just write out our equation. So we're going up, so we're starting with F. So F, what's going back? We have our 930. We also have this 1200 sine A. I think my G should be 120G, so minus 120G. And that would be equal to 1200 times the acceleration. With that max speed, it's going to be 0. So my force, what do we say, 50,000 over V is going to be equal to 930 plus 120 by 9.8. So let's just get the calculator out. That's going to give me 2106 on the right. So my V is equal to 50,000, my max speed, 50,000 divided by 2106. So my velocity is correct to 2 decimal places, 23.74 meters per second.